Hey there, Nick Hackers here. In this video, we're going to get into what led me into using Docker. I figured now would be a great time to make this video because Docker just celebrated their 11-year anniversary. And I myself am getting pretty close to using Docker for about 10 years. So I started using Docker in late 2014 with Docker 1.4. And back then, I was building and deploying web applications with Rails, Flask, using Ansible, etc. Very similar to what I'm using nowadays. And throughout this video, I'm going to explore some of the pain points that I had back then, and then go over how Docker helped me solve them, why I'm continuing to use Docker nowadays and plan to use it in the future. Now, if you're not using Rails, Flask, Ansible, or other similar tools, that's okay because there are some general takeaways here, of course, that apply to different programming languages, different tech stacks, even just running different applications instead of even trying to develop or build your own ones. So yeah, the takeaway here is Docker can help you solve quite a few problems in a general purpose way. And I think we're naturally going to explore that just going over this video here. And by the way, I do have a couple tabs open, this blog post, etc. We're not going to be really reading anything at all. This is a fully unscripted video, just kind of going over my origin story of Docker. So yeah, let's rewind time just a little bit to 2014. I believe it was in the summer or mid 2014, whatever. Some version of Rails.4 just came out and it happened to catch my eye. And I'm like, okay, Rails is probably something maybe I'll be interested in working with. Let me go and just see if I can run a basic version of Rails locally on my dev box, get a hello world going, play around with the framework and see if it's for me. Now, back then I was using Windows, I don't know what version exactly, maybe it was Windows 7, something like that. But even back then I was using Linux VMs to basically have my development environment because things like WSL and WSL2 were not available yet. So I did have some experience already working with virtual machines there. But in the Linux world there, yep, you still need to install all of your things to make your application run. So if you're talking about Rails in this case, you need to install Ruby, right? Ruby is the programming language that Rails is based on. But even to install a version of Ruby, typically it's a good idea to install that with a tool like a version manager tool. This is a very popular concept for many different programming languages, right? You can install different versions of different programming runtimes, and then you can just open up your terminal and have it switch to a specific version depending on what project that you're working on. In the Ruby case, there's quite a few different options you can choose from. Back then RVM was a popular solution. There's also RBenv, which is a separate tool. I'm pretty sure it existed back then because I remember one of the first rabbit holes that I went down was like, well, how do I want to install a Ruby? Should I just apt install it? Should I compile it from source? Should I use our version manager? And I ultimately landed on RVM back then because it just seemed to be, well supported by the community. It was recommended in a lot of blog posts. And if you're new to an ecosystem, you kind of just take that stuff as the truth to begin with because you don't really have anything to measure it against. Not that RVM was bad, it completely worked for my use case, but yeah, I did have to research what to even use there. But I remember installing Ruby there and it took like 15 minutes for it to install because I don't know what was the case. Maybe it was just like poor timing or, coincidental timing where there was no precompiled Ruby binaries available for my combination of like CPU architecture and OS, etc. So Ruby had to be compiled. Now, I didn't have to really run any commands or do anything crazy to make that work. RVM handled all of that, but it's like running a command and then waiting for 15 minutes. And 15 minutes is a really long time just to wait. But yeah, okay, so eventually Ruby was installed. Things were set up in such a way where I can just open up a terminal, run ruby -- version, and get the version that I want. Now, I don't remember the exact version of Ruby back then. Maybe it was version 1.9 or possibly even 2.7, but let's just say for the sake of this video that it was version 3. I know that's not the case, but it's going to make it a little bit easier to follow. So yes, I can open up a terminal and now actually do ruby -- version and get version 3 back. But that's just the beginning of the story, right? Now we need to install Rails and potentially some other stuff as well. So, eventually I get Rails to be able to install, but that wasn't just something I can do in one command because typically when you're installing different package dependencies for a programming runtime, some of them may end up having C dependencies that you need to install. So if you've ever tried to bundle install something with Ruby or pip install something with Python or npm install something with Node, you may get some type of error to be like missing C compiler, and then it recommends that you maybe install GCC. So that could be something now that you need to go and research, right? If I'm running in a Linux VM, I can just apt install GCC or some other packages that help install different tools. But after even getting that installed, you may get more specific errors. You may have seen these type of stack traces and failures to install dependencies where it's like, missing header file, blah, 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 .c or blah, 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 whatever, .h, right? And now you have to go to Google, decrypt that error message, Google around, hopefully find a solution, and then hopefully find a solution that works for you. Because oftentimes, you'll find a Stack Overflow or some answer where it's like there's 118 upvotes, but when you run it, it doesn't work because things has changed because, that answer is from 2 years ago. So, but yeah, let's say say that you track some of those C dependencies down and you get things to work. Cool. Now you have like your framework installed, some of the packages that you might need to build your application. But a web application typically isn't just running the web process and that's it. Maybe in some simple cases and certain specific use cases that is the case, but at least for me, I would say, 99% of the applications that I build that are web apps, it's way more than just running the web process. There's going to be a database, a cache, a background worker, maybe some form of full text search if Postgres isn't enough. Nowadays, it would be running things like ESBuild to handle compiling some JavaScript there, and then maybe something like Tailwind or Bootstrap for CSS and development as well. You want to have these containers running to incrementally change things as you make changes locally. But yeah, there's all sorts of different things that you need to run besides your web app, right? And when it comes to Rails specifically, it's very common to have a background worker in most applications. Back then, I'm pretty sure maybe Sidekick was available, but if you're using something like Python, you could be using Celery. And this concept of running a background worker immediately means that you need to run two different processes to actually make your application work. You have your web process that you're running, right? Your application server could be Puma or Unicorn, G-Unicorn in Python's world, whatever web server that you pick there. And then you have the background worker. But if you just run them manually, that means you need to open up two terminal tabs or windows and then run those commands. And that's kind of annoying. So you immediately have to start kind of solving that type of problem. Like, how do I run multiple processes together for my application? And in the Rails world, there's this idea of having a proc file, and Foreman is a tool to do that. And that's really nice. It's basically a text file where you can be like, here's a command to run my web process. Here's a command to run my background worker. Here's a command to run whatever else you need. And then you can run one command there, have it all up and running. And it handles, outputting all the terminal logs into one terminal window so you can see everything work, and it's pretty nice. Python has something very similar with Honcho. Cool. Okay. But then what about your database? So, with Rails, at least by default, it will nudge you in a direction to use a SQL database. You could be using SQLite, you could be using Postgres, or maybe MySQL. And in my case, I already had experience using Postgres, so I wanted to do that. Which means, though, I need to go back to my Linux VM there and then apt install Postgres because I'm, running Ubuntu there in my VM. And that's going to install whatever version of Postgres happens to come with that version of Ubuntu. But, let's say I want to install a specific version of Postgres. That's another rabbit hole I need to go down. Maybe find a custom PPA with Ubuntu or whatever to install a specific version of Postgres. And that's really only half the problem too, because maybe this project wants to use Postgres, 16 or whatever, but the previous project is version 15, maybe a legacy project I can't update. So you have to solve this problem of like, how do I install like multiple database services on different ports and blah, blah, blah. There's all sorts of different things that you need to figure out. Then after your database, you want to get something set up for potentially caching or your backend for your background worker, which a popular case would be using something like Redis, right? Redis is a great Swiss Army knife for dealing with all sorts of different problems around caching, quickly storing and accessing data, PubSub, it could be a message broker backend, etc. But yeah, there's installing that. And it's kind of funny too, because if you're on Windows and you're not using a Linux VM, there is no native port for Redis on Windows. Nowadays, it would be super easy to get installed in WSL. But back then in 2014, you're basically, in my case, going to be inside of a Linux VM, installing Redis in a very similar way that you installed Postgres. And, the same problem there with Redis, where you might want to use a certain version, is going to be the same problem as Postgres. It's going to be a little bit tricky to get different versions of that running for different projects that you have. But yeah, finally, you have your web application running, you have your background worker running, you have your database running, and you have your cache / message broker backend running. And now finally, I can go to my browser, run the application, and then see a hello world and be able to go into my code editor and then modify a file, go back to my browser, reload and do it. But I already had literally 10 years or more of programming experience before beginning that whole entire process. I can't even imagine what that would be like if you had no programming experience at all, or maybe you just started, maybe you did a little bit of HTML and CSS and it's like, now I want to get into like back-end programming and, you chose to use Rails or Python or Node or whatever, because you're going to run into very, very similar problems with that back then, at least in 2014. So right away, Docker was really, really nice. It kind of hit my radar a little bit towards the end of 2014, and it made that problem quite good. And before we even get into some of the advantages of Docker, there's all other little problems you need to figure out too when you're not using Docker. So for example, you just went through all those different steps. You got your application running in development and it's completely working for you on your dev box. For me, inside of that Linux VM, inside of my Windows dev box. What if I need to get a new dev box in 6 months because something broke or whatever? I have to redo all of those steps to get all of that to work. And if I didn't document all those steps that I took to get all of that stuff working, then it's going to be, not quite starting from ground zero again, but it's going to be a big pain in the butt. And this actually becomes way more apparent or problematic when you're working with a team, because then it's like, well, every single teammate now needs to go through that documentation, run that like 187 steps to get everything to work. And you know what? Guess what? And I'm guilty of this too. That documentation is going to get out of date. Something's going to work that used to work today, but it's not going to work 6 months from now because, that dependency doesn't exist anymore. That version got pulled. There's some network problem. This thing got changed to this. This maintainer changed the project to this thing. Whatever. There's a million different reasons why that thing may not work in the future. And these are some pretty big problems. And there's another problem as well, just around like version locking your dependencies. Now, Ruby makes this pretty nice because you can have a gemfile.lock file. And, with NPM nowadays, you can have a lock file too. You can use yarn, etc. Python has a couple different solutions for this one. Still not a solved problem. But yeah, the basic problem is this. You install all of your application's dependencies right now at this point in time, literally today. If you go and not lock down every single dependency down to its latest exact patch version, for example, version 1.6.4, instead of just having like version 1 with a little operator in your gem file or whatever it is to get the latest version of 1.6 or whatever. What happens when you install stuff in the future and you get a newer version and now it's like what you have isn't even exactly what you had 6 months ago? So you have to be very meticulous in making sure that you version lock everything. Because if you hire someone later or you run your application in a different environment later, without that lock file, then you're not going to get the exact versions, which may break things in unexpected ways, which is very problematic. And this is actually more of a problem too in production, which we're going to get into when we start talking about production issues as well. And also just on the topic of development stuff too, I mentioned teammates. This also goes if you're like, let's say, working on a startup type of thing and, you want to get your application up and running. You have it a little bit set up yourself, things are doing good, and you want to hire a contract worker. Now that contract worker goes into your code base, and it's like they have to follow that 187-step README file just to even, get things running. And you hope to God that, they're using a Linux VM too, because, if they're using Mac OS or something, all those different steps are going to be totally different for them. They're going to have to, basically start from ground zero with a little bit of help from, your docs to guide them at least to what they need to install. But do you really want to spend, 6 hours of contracting work to help them get set up? Now, of course, you want to help them get set up to be able to run your app so they can start providing value. But, those couple of hours or half a day or day, whatever it happens to be, getting set up, that's a lot of money to be spent on just like rattling through a README file there. So yeah, definitely a pain point. And of course, the next evolution of that one is if you want to make your project open source, throw it up on GitHub or whatever, have some community support. How hard is it going to be to get someone to get involved in that project if they just look at the installation steps and it's just like, apt install this, run this. If you're using a brew, do that. Else, if you're using it on Windows, you have to do this side step. No way. One, writing that documentation super not maintainable. And two, it's a big deterrent to even run your project locally for somebody else who's not super invested in the project like you are. So yeah, Docker helps a lot there. But in my specific case, Docker caught my radar in late 2014. And it's like, okay, cool. There's a way for me to, set up this thing called a Docker file, put the file system of all my stuff in there in one environment, a Linux environment of my choosing or whatever, the base image that you want to use there. Install all of my stuff there, kind of codify that into a certain file. And then I can just run some commands like a Docker compose command to run and build everything. And I can put all my different services in that Docker compose YAML file, like my web server, the background worker, Postgres and Redis and all that. I can run one command, have it all multiplex to my terminal, and it kind of just works. Now, back then it was a way different time. Docker desktop wasn't a thing. Back then, this idea of the Docker toolbox was kind of just coming around, and they had this idea of Docker machine where you can kind of, have the ability to run Docker on non-Linux systems, for example, Windows and Mac OS. Performance was a little bit sketchy back then. There was some bugs and whatever, but it was a solution that worked. You can begin to think like this is going to be a thing when it came to Docker, at least that I saw in my mind. And immediately it was starting to help solve my problem of just getting things all isolated to where, project A is within Docker with these versions of these tools here. I can do project B in a completely different set of, runtime versions, Postgres, etc. And there was that isolation there that just made things work nicely. And for someone like me who really has never had a full-time position, like working long-term at a company, I always have done contract work, freelance work, a lot of different side projects on my own. The last time I looked at my side projects folder, there was 170 different projects in there, a lot of them from 20 years ago up until today. So I've got a lot of different apps running with lots of different versions. And some of those, maybe it's an application I haven't touched in 5 years. I'm pretty confident with the Docker setup with, the locked dependencies and all that other stuff. I can just run it up my project without having to worry about it not working later. And that's a really, really nice thing to have. Those are just some of the pain points that I approach there in development and why Docker helped me a lot. Because now it's if it comes to open sourcing your project or getting your application running for some teammates, they can just do a Docker compose up -- build. Maybe they, copy an env file beforehand or whatever, but it's relatively easy, right? You just run a command or two after you install Docker and things work, especially nowadays with WSL2 and Docker Desktop, and, performance there is really nice. Things are getting better in macOS performance-wise. Docker is working on that every day. So here we are 10 years later, and yes, we have a nice solution for that. But yeah, let's go back to rewind time a little bit more and just talk about some of the pain points around deployment without Docker. And, earlier on in this video, I mentioned I was using Ansible, and I still use Ansible nowadays. Ansible is a great way, in my opinion, to help you set up and configure servers when it comes to the tools that are installed on those servers, right? So you can imagine having a virtual private server, a VPS, on DigitalOcean, AWS, right? Some Linux environment in the cloud. It could also be a bare metal machine that you own too, and it doesn't really matter. But, you have a base installation of Debian or Ubuntu, and it's where do you go from there? I need to install this. I need to set up a firewall. What about SSH, disabling root logins, and all this other different stuff that you want to have set up there. And Ansible TLDR just lets you codify all the steps that it would take to install those tools and configure them. And just like software development, you want to have a test suite that you can run locally to test to make sure that things actually work. How do you know that your Flask app or Rails app is actually working, right? You can go to the browser, click around, and make sure that it works, but you can also write some automated tests to do that too. And with Ansible, that's really no different. It would be nice to have automated tests too, but you can just run your Ansible code against a server and then manually look at those config files and make sure they align to what you want. But in a pre-Docker world back then, I wasn't super well versed in VMs, even though I had some experience using them, etc. But, I was spinning up virtual machines with Vagrant, running Ansible against them, and then doing my, manual checks to see if things worked. And if I wanted a brand new fresh VM to see if that stuff worked again, after doing a code change to my Ansible setup, I would spin up a different separate VM, wait, that's up and running, now run Ansible against it, and that was super inefficient because you know how it is when it's coding anything, right? You may make a little change, literally a one-liner change to something, save it, reload your browser, see immediate feedback. But what if the feedback is waiting for a VM to be provisioned, and then you can just look at it, we're waiting 6, 7, 8 minutes just to get some feedback on something. Now, back then, I was a little naive. I probably should have used VM snapshots. That would have made that process a lot quicker. But with Docker, it was way more easier because I can just set up a Docker container to be the target of where Ansible runs against, because there is a Linux environment running in there. And while it didn't work for 100% of use cases, because there are certain things that you can't really do inside a container versus a native base operating system outside of Docker, it did help me in the 99% case. So I was able to suddenly get feedback on my Ansible rules literally within seconds, because it was spin up container, run Ansible against it, check out things. Did it work? No. Spin up a new container, run it against it. Did it work? And that spinning up of a container took literally a second. So it wasn't even like a big turnaround time of waiting. So that was a really huge benefit for me there. And that's kind of just using Ansible in development to test my rules, but what about actually deploying web applications? Even independent of Ansible or any tools like that. Typically when you set up a server, at least in my case, it's going to be a Linux-based server where I'm running some web application. And just rewinding way back to, building your application, whether it's a Rails app or a Flask app or whatever, it doesn't really matter. Now you need to get your application running on the actual server. So in my case, it wasn't crazy insane because I was running Linux locally in a VM. If I'm running Ubuntu or Debian there, I can sort of run Ubuntu or Debian on the server, and some of those apt commands, some of those config locations are going to be the same. But if you're on Mac OS or using Windows without a VM, and now you want to install your app on a Linux VM, it's you're starting sort of from ground zero. You have to relearn all those steps there. And, again, without using Docker there, it's going to be a lot of pain just setting that up. And also when it comes to your server, the stakes are a little bit higher. You misconfiguring something in development is not a big deal. You fix it in 10 minutes or a half an hour, and then it's like no harm, no foul. But if you misconfigure your server, suddenly there's all sorts of different problems like, whoops, I left the port open. Now Redis is accessible over the public internet and there's no password on it by default. And suddenly people are connecting to your Redis server, getting like personal identifiable data that's cached in a non-encrypted way. Whoops, those things happen. In production, there's also interesting side effects of just not using Docker, installing your programming dependencies too, because on every single application deployment that you push out, you may have a bundle install command, a pip install command, an npm install command. And, what if something fails at deploy time because of a network blip? These things completely happen. And going back to the lock file thing before, if your dependencies aren't locked all the way down to the exact patch version for all of them, you may end up installing dependencies on your server that are different than what was tested in development or a CI environment or, whatever pre-prod environments that you have set up. So these are really big problems here, and it could affect your application. They also take time, it's uncertainty, etc. And Docker makes this quite a bit nicer too, right? Like I'm using Ansible still in deployment stuff now because I figure, these tools work hand in hand. I can use Ansible to set up my server to have all the tools that I want installed, configuring SSH, firewall, some security stuff, users, all those different things that you would have. But Docker is fully running my applications. So it doesn't really matter if I'm running a Rails app or a Flask app or a Django app or a Node app or a Phoenix app. And by the way, these are all example Dockerized apps I have up and running, or, they work in development and production, all open source, no strings attached. But it doesn't matter. It doesn't really matter at all because the implementation details about what's running is contained in the Docker Compose file. My server is the same for all of them. Once Docker is running all that stuff on the server there, then, I have a Docker image that I can just pull down on my server. That image was built and tested in CI or maybe my dev box, whatever it happens to be. I can have confidence it's going to work. Even if my versions aren't locked at the application level, lock files, the Docker image has the version that was tested. So in production, when I pull down and run that image, it is going to work the same way that it was tested in. So there's a lot of confidence there. There's no screwing around with this. There's no version managers that you need to switch around to and kind of juggle on your server. Like Docker's going to do all that isolation for you. And that's a really big advantage there too. And then also, you can progress into different ways of deploying your containers. You can have one server with Docker Compose. I do that for most of my stuff, but there's also Kubernetes. You can scale things out horizontally, blah, blah, blah. That's a whole other topic in itself. But yeah, these are just some of the advantages of using Docker when it comes to deployment. I'm sure there's millions of other ones as well. This video needs to end at some point because I can ramble about this stuff forever. But here we are 10 years later, 2024, still building and deploying web apps with Docker. And I am really happy. I don't see myself stopping. And I congratulate Docker on their 11-year anniversary. Hope for the best. I continue to use them. So before we wrap this up though, let me know, what's your origin story with Docker? What led you to using it initially? Are you still using it nowadays, etc.? With that note, if you liked the video, please give it a thumbs up. It really does help a lot. Thanks a lot for watching, and I'll see you in the next video.